And now we're going to build that solution. And I just mentioned the tree before about the natural solution for this. And I'm going to stop here to explain why the tree is also relevant for the solution and not only for the first principles fundamentals of the problem. First of all, as I mentioned, a tree is just the natural topology to send the content from a source to a destination. You have one single point of source and then multiple destination that is a fan out. That by nature is a tree. But you may want to leverage more connections between all the devices in the network to make it potentially more resilient or more robust, at least hypothetically. That is what would be essentially a potential approximation to that. But the reality is that you are trading it off against other things that are usually worse than the actual intent of the solution if you want to create those many connections. Those many connections between the different devices across the network is what we call a mesh. And I'm going to go into a little bit of details about having a mesh does not help you. First of all, if you want to have the content readily available and as fast as possible into your audience, that essentially is paramount to have well quality of experience, what you need to make is the fastest and most efficient delivery of the content from the source to the destination. And that means that you don't want to have multiple paths for the content to be delivered. And if you have multiple paths, essentially what happens is that you are achieving less efficiency and more overhead. Why is that? Because instead of having the right way to deliver the content, you are delivering the content from multiple places at the same time, that at the end of the day is going to increase the overhead and reduce the efficiency. Why is the overhead increased? First and foremost, because you don't know where the content is. When you have multiple sources, you need to either discover or wait for somebody to tell you where the content is. And those seconds are precious, right? If you are waiting for somebody to tell you where the content is, you're already late because what you need is a change in the network, right? What you actually need to do to solve the problem is change the network before the impact happens, right? And if you have continuous connections open to multiple sources, that is going to be also another source of efficiency reduction. That is, instead of having the optimal path of delivering the content, for example, here the tree that we look here on the right would be the hypothetical optimal delivery path. If you do it this way, essentially what you are doing is replicating the content on several paths to make the content go from the same source to the same destination that is assigned to this node. And what that means is that essentially you are duplicating the traffic from different paths, or you are waiting for somebody to tell you where the path is, and then you need to pull the content from that source. That may be this guy, maybe this guy, maybe directly from the CDN. And meanwhile you are doing that, you're waiting until you know where the content is coming from. Meanwhile, if you set up the correct topology from the get-go, then you are ready to deliver the content in a proactive fashion from the CDN all the way into the nodes in a fast-forward manner without having to decide at any point in time where the content is. This is relevant because there are many approaches to trying to solve these problems that tackle the technology this way through a mesh, but we truly believe that the tree is the way to go because it's the right fitting. And we can go now into why that is relevant. So here you can see two different topologies. On the right, the same tree that we mentioned before. On the left, a scenario that is essentially connecting everything to the CDN, okay? You can consider that it's still a tree, but it's a different kind of tree. Here we are leveraging the end user devices to make the connections through the right path. And this is really relevant because the right path may not be between the audience and the CDN directly. Maybe the right path is going through a different route that is leveraging the end user devices in order to make the content arrive faster. So if you have that option, then you have the option of building a tree like this one. But if you don't have that option, you are just relying in the most simplest scenario to have a tree that is essentially flat, everybody connected to the CDN. And that is one of the sources of the problem. You start getting the audience, you see this high surface tension area over here that creates congestion, that creates bad quality of experience to your audience. Of course, if you do that, you are creating a less efficient scenario. Essentially, you are hitting the limits of the infrastructure. Meanwhile, if you do something like this, you may see that these links are highlighted in green, and that's because this surface area is reduced to a smaller surface area here. In this toy example, is just one connection, but we will see later on how that shows up in reality, in production data, okay? So you may realize here that instead of having, in this toy example, 5 connections to the CDN, here we only have 1, okay? So it's clear that this is more efficient in terms of the saturation of this surface point between your audience and the CDN. But not only that, because of the leveraging of the end user devices, we're able to minimize the load of the peering points between the CDN and the ISP that provides service to that CDN and the next ISP that is providing the service to the audience. In the example that I mentioned before, 2 ISPs that get saturated in between, the same happens here. Let's say, for example, that this area over here is the surface area or the surface contact point between ISP A, that may be these 2 guys, and the other 4 ones. The surface area here right now is just 2 points of contact instead of the 5 that we had before. And that essentially is also making that interface more efficient. What we are doing at the end of the day is choosing the best paths in every hop to make the content delivery arrive in the most efficient manner. And that at the end is going to allow us to avoid the congested points and serve a larger audience. And also, by the way, increasing the quality because we are doing so. Instead of having, for example, limitations in the bitrate that we are going to get degraded between, say, 4K into 1080p or 1080p to 720, because you have congestion of the network between those points. And essentially what you hear and what you see as the audience is that the bitrate is going to be degraded. Here we are avoiding that problem because we are taking the best path on the delivery chain. And last but not least, you also get more efficient cost structure because you don't need to rely on expensive CDNs to grow the capacity to deliver the content to your audience. You can rely on the audience itself to absorb the load of a large event. And we'll see also the benefits of how that mapping that is counterintuitive, that the larger the audience, the better the quality of experience and the better the load that we can achieve in these kinds of scenarios. But here, even this toy example, you can see straightforward that instead of having 5 copies of the content delivered from the CDN to the audience, we have in this interface over here only 1 copy, and then only 1 copy in these branches over here. So at the end of the day, this is a more efficient way to deliver the content, and the efficiency translates to better quality and also better cost structure, so reducing your operational expenses and also making the service financially more attractive, and at the end of the day, higher revenue. Okay, so let's see how that reflects in a real world environment. Okay, I'm going to start with the good things, for so to speak, and then we're going to see how that is happening. This is actual production data. It's from one of our largest customers in the US, and this is an organic event that they run without early announcement to us, because essentially they are providers at the end to all the customers. And we were not, of course, aware that they are going to have that event, because even then we're not aware that this event was going to happen. But here we can see the benefits of this kind of technologies deployed on the field and in production with live events, with customers that essentially are not letting you know whenever this is happening. And this is the best scenario of a live event that you don't want to be called in the middle of the night because essentially not working correctly. Here in this scenario, we achieved to provide the customer with 94% of the content in the highest rendition. In this case, they were using 1080p, and the rest of the audience was, of course, delivering 2% slots on the other qualities. But essentially, we were able to match that quality of experience requirement with this kind of network that sometimes is a question how that can be happening, specifically if we are relying on end user devices. The tricky here is to make it happen with the right data and making the right decisions on the network to guarantee that this is sustainable. And we're going to talk a little bit later on that. Second, of course, in order to make that happen, you need to have a good amount of traffic being delivered by the P2P network, otherwise you are not achieving that goal. And in this case, we had 78% of the traffic through the P2P network, while 22% of the traffic was flowing through the CDN in a traditional manner. Of course, whenever you have a significant amount of the traffic being delivered through the right data path, then is when you see the benefit of the quality of experience and also the benefits of the cost. So I'm going to show you a couple of examples of how that is showing in production data. I'm going to start still with a small scenario. This is just 50 nodes, but it's to show you that this is not just bells and whistles in a PowerPoint chart. This is actual production data. Here we have 50 nodes. It's still small, but it's not the toy example that we used before with just 7. This is 50, okay? Still a small event, a small live event for any kind of measure, but still interesting to see how the difference between 7 nodes and 50 actually means in terms of benefits of quality of experience and cost reduction. So here in this scenario, this is a different visualization because it's coming from our engineering dashboards. Essentially, what we have here is a network topology that here is reflecting the CDN, so the source, the same manner that we are using on the previous examples. But here we have a slightly different way of showing the tree, just to have it more visually available inside this slide, essentially showing all the other circles as end user devices that are sharing the content to each other whenever it's suitable. And you may realize that not all of them is sharing content to anybody else, because not all of them may be suitable. Maybe they are not capable. Maybe they are under mobile connections and we want to avoid to use them because they are usually metadata connections, things along those lines. But still, with only a subset of the audience able to relay content, let's see what we are able to achieve. Here you can see that only a subset of the audience, so this guy over here, 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 this one, and this one, there is a small set within those 50 are actually relaying content to somebody else. And the rest is essentially on the, what we call leaf area of the tree. They are at the end of the delivery chain in the tree leaf area. So essentially on the original diagram on the right-hand side, the audience normally getting the content for whatever the best source is. And in this case happens to be most of the time through other end users in the audience. With a toy example like this, that is only 50 nodes, let's see what happens at the end of the day. This is the timeline of an event. So we have the span out of the event kicking here. And then what you see is an initial spike of traffic, of course, coming from the CDN because the nodes just arrived and they want to have the initial content coming by. But before we reach the peak of the event, we start seeing a declination of the consumption of the CDN traffic, and the peer-to-peer traffic starts to pick up. And here, from this point onwards, you're already having 50% of the traffic on the peer-to-peer network. And it continues to grow up until we reach a stable point here, while the event is still receiving content and still receiving audience requesting that content, but still kicking the optimal scenario that in this case is 98% of the traffic flowing through the peer-to-peer network. Here we can see the actual production chart where we were hitting a constant 98% of the traffic. Okay, this is of course a cherry-picked scenario because it was a good performing one, but still I think it was very compelling to show you what is possible with an organic scenario with nobody essentially preparing for it. Now let's go into even harder scenarios, okay? So let's see actual production data from larger events. I'm just using here a toy example just to, you can see the mapping between the small scenario and how it maps to the actual production data. The actual production data is the last one, the chart that we have over here. So this one is actually more than 1,000 end user devices. Each green dot that you see here is an end user device. And the CDN is essentially here on the root, is even barely distinguishable, but essentially all these connections that are happening over here are in the first layer, just the CDN surface point, and the rest from this point downwards. So essentially all this area over here are the traffic that we send over the peer-to-peer network. You may clearly see the potential of the expansion of the capacity of the delivery chain with an architecture like this and a technology like this. You get the benefit of being able to overcome the limitations of the infrastructure that usually is constrained to achieve these kinds of capacities. But not only that, you're able to do so in a manner that is essentially uncorking the clock and achieving higher quality for the delivery chain, all the way from the root to the leaves and all the stages in between. Also relevant, you can see here that the surface area on the last part of the tree that is able to absorb all those users that are not able to relay content, either because, as I mentioned, they do not have the capacity. We monitor constantly in real time with those second granularity if they are capable of not, and also if they are not able to do so because we detect that there is a cellular connection and they shouldn't be relaying content by default, or if they want to opt out, any kind of situation that forbids them from relaying content, they are going to be well located here in this area of the tree at the bottom and receive content naturally as if they were part of the delivery chain in a traditional setup. And also with better quality of experience because you are avoiding the bottlenecks and you're rising the throughput that you're able to provide for a large audience at the same time. So I think with this, we have covered quite a bit of ground. I want to just to do a quick recap of how this relates with the initial scenario that we just mentioned. In the initial scenario, you may recall that we mentioned that one ISP may have issues with another one, but at the end of the day, it's just a scenario of congestion that can happen at any point in time. So what is the solution doing here is that every time that we see a congestion point, let's say, for example, in these two guys over here, or maybe this guy over here, what we do is we rearrange the network topology in real time, in the middle of the session, for whole audience. We optimize the whole network, we detect what is the right layout of the topology, and we apply the right topology on the fly for the whole audience before the impact actually happens on the video player. That allows us to essentially avoid that congestion event before it gets propagated downwards, and that allows us to strive for the best optimal scenario, and of course, at the end of the day, avoiding that midnight call that we all brew in order to avoid it once and for all. Of course, this is not going to be the silver bullet for all the scenarios in the world, but most of the scenarios that are related with these kind of issues that are usually congestion associated with capacity on any point of the delivery chain are solved by these kind of techniques. So just to recap, important things that are relevant in order to unlock the possibilities that this opens. First of all, have visibility of the quality of experience data that is specific for your streaming event and not using community data. Then visibility over the network that allows you to identify where the capacity limits are. And it's not only on the last mile, you also need to have that visibility on the middle mile. And with a tree of end user devices, you are able to discover and leverage it. And at the end of the day, the accurate quality of experience and performance data that enables you to do this kind of automation. If you have the right information where you know that a quality of experience issue is caused by something that is in the right vicinity of the end user device and not something far away, you know that there is a potential solution here, changing the connection on that point. And with that, actually, we're able to solve the last mile and the middle mile problem because we are steering the traffic away from the middle mile point of congestion. And then we can steer the traffic between different ISPs, between different CDNs, between different local sub-area networks within the ISP, everything on the fly, everything without having to have operations teams looking at this. Everything completely automated and based on actual data from the audience.